various examples of systems of particles and rigid motion, and we realized that the central important concept to study such problems is the concept of center of mass. Then yesterday we further we further went further to realize and we introduced the concept of the velocity of center of mass. Similarly, the acceleration of the center of mass, these two concepts were introduced, and then we also discussed a case in the simplest of a multi-particle system, a two particle system, where the motion was separated or split into the motion of center of mass and other one is what is called as relative motion or the concept of effective mass. And so we had calculated the total kinetic energy of the system, of this two particle system, then we realized that this kinetic energy of this two particle system can be split up into that corresponding to the center of mass and that corresponding to the reduced mass, and okay, and it appears as if the reduced mass rotates with the relative velocity between v1 and v2. Then yesterday we proceeded further to study the systems of particles, and we realized that we required some additional concepts like how do we generalize the concept of momentum, acceleration in the case of systems of particles. So we had introduced the notion of the velocity of center of mass, the acceleration of center of mass, etc. We considered a very interesting example in the case of a two particle system. How does it go? And it turned out to be that the motion of this two particle system, suppose I look into the kinetic energy, this total kinetic energy can be split into two parts, one corresponding to the kinetic energy of the center of mass and the other one corresponding to the kinetic energy of reduced mass. What is the velocity of the reduced mass? It is the relative velocity between v1 and v2. These are the velocities corresponding to two particles, and today we proceed further to study rotational motion of systems of particles. Remember, in the case of systems of particles, it can be either pure translation or it can be pure rotation or both. So we need what I can say that how to deal with rotational motion, and we need to equip ourselves. In today's topic we are going to consider vector product, which is when we have two vectors a and b, what is the cross product between these two vectors. We need this vector products and angular velocity. If a body rotates about an axis, then it will have every point on it will have an angular velocity, correspondingly it will also have angular acceleration. Every point on this body. So we realize, you see that we are gradually equipping ourselves with various concepts and methodologies as to deal with systems of particles and rigid motion. And okay, so this angular velocity is general denoted by omega vector, and angular acceleration is usually denoted by alpha. These are fairly standard notations. And now we have to do some little bit of you may think that it is mathematics, but it is not. As I keep repeating in my lectures, do not be scared of mathematics. At least at this level, treat whatever mathematics you are coming across as a tool to study physical problems. And so first we will have vector products. Now before that, just suppose I have two vectors a and b. Earlier you would have come across what is called as the dot product between these two vectors. The dot product, the so called the dot product, a dot product of two vectors. It is defined as a dot b is equal to modulus of a that is the length of the vector A times the length of the vector B times the angle between them, these two vectors. Now one simple example for this is suppose a force is acting on a particle, let us say a force vector is acting on a particle, this is the force vector let me say, and then it moves by a small distance, displacement ds let us say. Then the work done by the force on this particle is, in moving the small infinitesimal displacement is f dot ds, right. Then we are moving this particle from let us say a particular point A to a particular point B, then the work done by the force on the particle is integral f dotted with the ds integrate from A to B. So these things you would have come across. Now we are going to, so the dot product between two vectors is a scalar quantity, it is a scalar, it is not a vector, it will be a number. Now we are going to consider what is called as vector product between two vectors. It is defined like this. Suppose I have a vector, I have a vector like this, sorry, this is vector little vector A, this is little vector B. See there, this vector A and vector B, they are not perpendicular to each other, they make some angle. They can be perpendicular, in general we need not take it that way. So the angle between the vector A and vector B is theta. Then the cross product between these two vectors is denoted by another vector C, which is perpendicular to both vector A and as well as vector B. Therefore this vector is perpendicular to the plane formed by this vector little a and vector little b. So this is denoted like this, and we have to give a direction to it. I will explain what it is in this. Now we need what is the concept of a right handed screw. I will explain here. What is a right handed screw? Suppose I have a screw like this is the tip of a screw. So these are the what you call as screw edges, and then this is the axis. The concept of a right handed screw is like this. Suppose this denotes the direction of A, and then you have this is direction of B. I am denoting the same thing actually. Actually I could have drawn a screw here itself, but I did not want to complicate the diagram. Now when you rotate from A to B, the screw has to advance in the forward direction, the screw has to advance upwards. So this situation is denoted like this. What is a right handed screw? Okay. Now let us say that this middle finger, it can point out in any direction, this denotes little a, okay, and then this vector, I mean this is very difficult, as if you have to view this entire thing is a point here and it is pointing in some direction, this vector is little b. So the angle between these two is some theta depending on how I fold it. Now the thumb denotes the direction of motion of advancement of the screw. When I rotate from A to B, the screw has to advance upwards. Let me again do it, and when I rotate from A to B, the screw advances further. This is what is called right handed screw, and you can also have a left handed screw, we are not worried about it, and we will follow this standard convention. So the cross product between these two vectors little a and little b is modulus of vector A into modulus of vector B into sin theta, and remember this rotation is indicative of the direction, it is a vector quantity. I need to denote, I will put a unit vector here. So this is the unit vector. The unit vector is such that it follows the convention of a right handed screw, and okay, this is. Now how do you take this angle theta, sir? How do you take this theta? Now depending on the angle between A and B, theta can be less than 180 degrees or theta can be greater than 180 degrees. The convention is theta is taken through the smaller angle which is less than 180 degrees. Okay. So when two lines intersect, you will have two angles, one is theta and another is opposite one. So it depends which one you will take. It is always taken as the smaller angle which is less than 180 degrees. This is the concept. Now this vector product between two vectors, they have various conventions. First one is various properties. First one, A cross B is not same as B cross A. Suppose we are taking A cross B, it is not same as B cross A. When you take B cross A, you are rotating from B to A through the other way, right. So this is same as minus B cross A. These are the things which you can convince yourself. Now under reflection, what do I mean by reflection? A goes to minus A and vector B goes to minus B, then A cross B same as minus A crossed with minus B. So under reflection the cross product remains the same, it remains invariant. Now from one easy property is third property. What is A cross A? Because the angle is going to be 0, therefore it is 0. So cross product of any vector with itself is 0. Now we come to unit vectors of a coordinate system. If I have here, let us say this is I, J, K. Here the angle between each of this, any two of these vectors is 90 degrees. These are the unit vectors. So this is what you call it as IJK system. Remember, sometimes this is also used as EX, unit vector along x direction, unit vector along y direction and unit vector along z direction. Such a convention is also there. So you should get confused when people use different notations. And so you can see that what is I dot j, you take I dot j, automatically it will be k. So it is cyclic. Similarly j dot k is equal to I. What is I cross I? I crossed with I, what is it? It is 0. The cross product of any vector is itself. Therefore there are 3 vectors, there are 9 products. So you can realize that only 2 of them. Suppose you take j cross I. If you take j cross I, it will be definitely the unit vector, the vector represented by j cross I, it will be in the direction perpendicular to both, but you are taking the cross product in the opposite direction, therefore by this property it is minus k. Okay, right. So these are the various properties of dot products which we will be using extensively. Now there is a general mnemonic formula. When I have, let us say, A is equal to Ax I plus Ay j plus Az k and vector B, these are all in Cartesian notation. So x component times I plus y component times j plus z component times k. Then A cross B, it is calculated as a, there is a formula, this is a kind of mnemonic, it is a determinant I j k Ax Ay Az Bx By Bz. How you calculate, I am going to tell you. First you know determinant can be expanded through any row or any column, but it is only a mnemonic, you cannot do it here, you have to always do it through first row. It is a kind of way to remember, a methodology to remember I. So leave this column and this row, you will be left with this determinant. So what will be this ay, it will be ay bz minus by az. Then minus j, actually what you do now, I will erase what I have done here, these things I can remove, I am going to write the second component. So I am j, I take this as lead element, therefore this column I should leave and then this row I should leave. When I do that, I will have, I put a minus sign, this will be ax into bz minus bx times ay. So ax bz minus az bx plus last component. So for the last component, what should I do? I should leave this column and this should row. It will be ax by, it is ax by minus bx ay. Okay, this is how you calculate. So you should try to do various such problems from books. Now I will take a simple example and illustrate an important property of cross product, which already we have said, but just as an illustration. Suppose I take two vectors. One vector is one vector A is I plus 2j plus 3k, and then B vector, I can take arbitrarily any two vectors, it is 2i plus 3j plus 4k, take any two vectors. So I want to calculate what is A cross B, it is very easy, I j k, and then component is 1 here, 2, this is 3. The components of B I should write here 2, 3 and 4. I guess you realize that these two vectors are not perpendicular to each other, right. Now this will be I times 4 into 2 8, 8 minus 9 plus minus j into 4 minus 6, 4 minus 6 plus k into unit vector k into 3 minus 4. So this is minus I, then this is plus 2j minus k. This is the A cross B vector. Now what I will do, as I tell you, when I have two vectors, one is A, another is B, this is A, B, this is going to be the C vector, right, this is the C vector. Since the C vector is perpendicular to both A and B, that is what our definition says, let us check up. So I shall calculate C dot A. When two vectors are perpendicular, the dot product should vanish, is it right? Let us check up. Minus I plus 2j minus k dotted with, I take A, so I plus 2j plus 3k. So this will be minus 1 plus 4 minus 3, it is 0. So it is clear that when I have two vectors A and B, whatever angle they make, when I calculate the cross product A here B here, then it will be perpendicular to both. So this vector dotted with either A vector is 0, this vector dotted with B vector is also 0, okay. So you need to master this kind of calculations by doing various problems from standard textbooks, okay. Now why did we introduce this vector product, sir? Now it makes our life rather easy to study angular velocity and angular acceleration, and this vector product is a very convenient tool to study these things. Let us see how we do that. So remember, we are going to study the motion of a rigid object, so we will see. So I am going to consider the motion of a rigid body about an axis. I need to draw a reasonably good diagram. So I have an axis, let us say this is the axis about which it is rotating, then I consider I will draw this a different colored chalk, so that I will explain what it is in a minute. I am going to consider a point here, I am going to consider a point this I am going to consider a point, I will let me have the axis, this is x axis, sorry this is y axis, this is x axis, this is z axis. So about this axis, this is the O origin, about this axis O the rigid body is rotating. I consider a point P, that is what I am doing here. Okay. Now it let us say that as the rigid body rotates, this particle P will move on the tip of a circle. What I have denoted here is the tip of a circle, usually in textbooks they denote it by slotted lines. Okay, this is in a plane, this colored circle, the rim, this is actually in the plane here like this. I will call this point as C. Now when it rotates a little, it goes by an amount delta theta, angular displacement is delta theta. So this point is P prime. So by the when the particle moves from P to P prime, the angular displacement is delta theta. So delta theta angular displacement. So you need to get these basic notions very clear in your mind, and this is what, it is a fixed axis, please remember that it is a fixed axis. About this axis this rigid body is rotating, and now there is this concept which is generally books do not care much about it, but I think we should, the what is called the average angular velocity, average angular over the interval delta t. Remember, in the time delta t, the infinitesimal time delta t, the point P moves from P goes from this particular position to P prime, and the corresponding angular displacement is delta theta. And remember, all these things are happening in a plane perpendicular to this board, you can see from the top. Okay, this is given by delta theta by delta t. Now you take the limit as delta theta by delta t as delta t tending to 0. See, these calculus notions are very essential to understand this kind of problems. This is given by the derivative of theta with respect to time. This is what is known as instantaneous angular velocity omega. Remember, this velocity is a vector quantity, so will be the angular velocity. So what is the direction of omega? So strictly speaking I should not write like this is only the magnitude. So the direction of omega, okay, the direction of omega is such that yes, now you would have guessed what is going to happen, because the rotation is happening in a plane, therefore the omega direction is, it will be given specified by the it will be specified by what is it, the right handed screw. So when it is right handed screw is this is how it will be, right. So this is the direction, and so when you rotate like this the right handed screw would advance above, right. Now we will what is the relation, where is going to be the linear velocity? Linear velocity will be here, this will be tangential at the particular point P, it will be it is at the particular point P, it will be tangential to it. And now we need to get various relationships, this particular circle alone I will amplify it and draw it here. This is the top view, when you are seeing from the top you can see that, and this radius is, let us say that I will take this radius as r, and I will have an angle, it goes by this amount, this is delta theta, this is ds, actually is joining this. So r times delta theta is what is delta s, so r into delta theta by delta t is delta s by delta t. Now the limit as delta t tending to 0, the limit as delta t tending to 0, this relationship will become r into d theta by dt is equal to ds by dt is the linear velocity, because delta s is the displacement. So it will be v. This is the standard relation r omega is equal to v, which one studies at when you consider the motion of a particle along a circle, and right. Now we need to consider this how v is a vector, omega is a vector, look like a circle because we are viewing from side, and this is the fixed axis. I consider a particular point O, this is the point C, this is the point P. So it is going to be this is the direction of linear velocity, this is the direction of angular velocity, these things we have fixed it. Right. Now I better so I am going to join this point sorry. So this is the point origin, this is the position vector r, this is what generally known as r perpendicular. This is also a vector, from here to here it is a vector, I am just denoting the magnitude, right. So our now we consider omega cross r. What is omega cross r? Omega is here, r is here. Omega cross r is same as omega crossed with OC. This vector is same as this vector plus this vector. So OC vector plus CP vector. So this will be omega cross, this vector product is distributive, that means this crossed with this plus this crossed with this, OC plus omega crossed with CP. You notice that the direction of omega and direction of OC are the same, therefore this will vanish, this will go to, this will become 0. So, we will have omega cross r is equal to omega cross Cp. See, omega cross Cp is perpendicular, omega cross Cp is perpendicular to both omega and Cp vector, and what is the vector which is perpendicular to this as well as this, that is this v vector. Okay. So, let me repeat this, this omega cross Cp is perpendicular to omega vector as well as c vector. Now, we already have a vector or vector direction which is perpendicular to both these directions, that is the direction of Cp, and since omega and Cp are perpendicular, this is perpendicular, this is perpendicular, therefore, when I take the dot product I will simply have modulus of omega into modulus of Cp, this is nothing but this is, what is the length of Cp? Length of Cp is what is called as r perpendicular, r perpendicular. So, therefore, we have this relation omega cross r is equal to v. Now, so for the relation, what is that we have done? Omega cross is a vector of magnitude omega perpendicular and is along the tangent to the circle. So, the linear velocity v at p has the same magnitude and direction, that is what we have seen. What is the linear velocity? What is the magnitude of linear velocity omega? That is the calculation which I have shown here, r omega, and linear velocity is perpendicular to r and omega, therefore, we say that omega cross vector omega crossed with vector r is equal to v vector, and this may not be a very rigorous way of looking at things, but the geometry gives us an insight. What we have done is, let me again repeat, first we consider pure circular motion of a particle, then we showed that r omega is equal to v, that is what usually done. Then we consider here, we take two vectors omega vector as well as r vector and consider the cross product, and when we do that we realize that this omega cross r vector is same as omega cross Cp vector, and its magnitude when we want, this is not correct, I will when I need to write a step here, better I will do it here. So, now omega cross Cp is equal to omega, I need the magnitude of this, this is omega cross Cp vector, this is same as omega times r perpendicular. So, omega cross vector is perpendicular to both omega and vector r, and its magnitude is given by omega r perpendicular, and it is in the direction tangential to the circle at point P. So, from this we identify both must be the same and write that omega cross r is same as omega cross r is v. Okay. Now, we will be making use of things. See, for rotation about a fixed axis, the direction of omega does not change. If you are going to have a fixed axis and rotate, omega direction will be always shown by the thumb. In a general rotation, omega may change from point to point, etc. Angular acceleration. Next concept is angular acceleration. d omega by dt, I am going to the angular velocity vector, differentiate it with respect to time, that will be equal to the alpha, which is reserved for angular acceleration. Okay. Now, we will we have v is equal to, we have few important relations which we are going to get. we have starting from v is equal to r omega. We will not do very rigorous derivation of these relations, but we will prove, we will in a way, I will give you an argument. And so we have v is equal to r omega, differentiating both sides with respect to time. So differentiating both sides with respect to t, the time, what do we get? Dv by dt is equal to dr by dt times omega plus, and remember the particle is actually moving on this, therefore I need to write only this rigid body, therefore it is nothing but this is what is dr by dt, sorry, dr by dt is 0, therefore I need to write the other term r plus d omega by dt. This is not going to change for a rigid body, therefore it is simply r alpha. D omega dt is alpha, where alpha is nothing but the magnitude of, where what is alpha? Alpha is the magnitude of the vector alpha. Okay. Now I consider a quantity what is known as acceleration along the tangential direction. This is, you know, the linear velocity is tangential to circle at the particular point P, therefore I can talk about dv by dt. So dv by dt is equal to, that is what I have, r alpha. Now yeah, I can show that, but we will indicate this is at vector at is what, this vector at would be alpha crossed with r. How do I know this, sir? The tangential acceleration is alpha cross r. What was the angular velocity we got when we wanted to have the velocity that is tangential? It is omega cross r. In the same way, at I write it as vector alpha cross vector r. It is for you to convince a little. We will give you a rationale. Now, so I will only indicate that, compare this with, sometimes life is easy if we make use of analogies, but we need to check. V is omega cross r. Now I will call something else as radial acceleration. Radial acceleration. First we will calculate this. We know from the motion of a particle in a circle, it is, this acceleration is v squared by r. What is v? R omega whole squared by r. Okay, this is equal to r omega times omega, right. It is better I write the other way. Omega times r omega. So I know this is now by analogy again, what is AR? Maybe I will write it here, you will be able to see. By vector AR is equal to, by analogy, omega crossed with, what is r omega? What is r omega? R omega is actually this magnitude of the vector which is obtained from omega cross r. Therefore, it is omega crossed with r vector. Okay. Let me again give an argument. This I can write it as the radial acceleration as omega times r omega, by analogy with this angular velocity and tangential acceleration derivations. Similarly, I can write this as this vector quantity, I can write as omega cross r. Okay. So this the tangential acceleration will be along this direction, whereas radial acceleration will be along this direction, right. So I do all time irukku. 41 minutes. Oh, okay, then fine. 13-14 minutes I can conveniently complete. Now we will proceed further. So now only we are studying rigid dynamics. Earlier we have studied already, it had been introduced to you, motion of a particle in 2 dimensions. So a single particle can go around an object, it is something like planets going around sun, etc. So we will derive relations for that, and from that we will see that how these relations actually gel with that of rigid dynamics, and it is fairly simple, you need to be attentive. Okay. So now I consider a particle moving in dimension, particle in 2-dimensional motion. Okay. So I have here, this is x axis, I will take for some convenience y axis. So this is a point, this is the r direction, position vector, no, therefore r direction. So unit vector ER would be like this, along this. Now I can have the 2 directions here like this, let us see what happens. And r is equal to, now I am going to use what is called as a circular polar coordinates, very simple. What is it? X is equal to, x coordinate when I drop the perpendicular here, this quantity is x r cos theta, and whereas y is r sin theta. Cos, this is the theta direction, cos theta, sin theta, it is fairly simple. And okay. Now if I consider this vector to be this magnitude of this vector to be 1, simply I have x is equal to cos theta unit vector, then y is equal to sin theta, that is it. So I have such a vector, so dr by dt, r is equal to magnitude of the vector times unit vector, right. So I have, this is dr by dt times unit vector r plus r times der by dt. This is the time derivative of the unit vector along the radial direction, is it right? That is what I need to calculate, and it is very simple. This I know, what is dr by dt? The dr by dt is what we will call the r dot. The r dot denotes, this dot denotes first derivative, taking derivative with this. This is again a very standard notation. And so this is r dot times er, this quantity is what I have here, plus r times dr by dt I have to calculate, der by dt I have to calculate. So I know my unit vector er, as I said here, is nothing but cos theta times Ex, this unit vector is cos theta times Ex unit vector along this, plus sin theta times unit y. So therefore I d by dt of Er is equal to minus sin theta Ex plus cos theta Ey, right. Now if you look at this vector, that times there is one time derivative I have forgotten, I should write this, cos theta times theta dot. Similarly here when I differentiate minus sin theta times theta dot. Now what is this vector? Look at this vector is perpendicular to this vector. If I take the dot product between Er and then the resulting vector, it is minus cos theta sin theta 0 the times theta dot plus sin theta cos theta times theta dot. Therefore the dot product between Er and then the resulting vector is 0, therefore this vector is the direction of E theta. This is one way of looking at things. So I have here dr by dt, sorry I forgot to write, nobody noticed, this dr by dt is equal to r times dr by dt is theta dot E theta. I will keep it here. Some cosmetics I have to do so that I earn space. Please remember what is theta dot. Theta dot is d theta by dt, angular velocity, magnitude of that here, that is what we want. Now in a rigid motion, what happens when I have a disk and I have the point at a particular position whose position vector is r, then what happens to this r dot? Its r dot is 0, therefore r dot is 0. I will have only v is equal to r theta dot. V is in general we call this as for rigid body it is 0, in general we call it as this is radial component times ER plus this is the angular component of velocity times E theta. Now for a rigid body r is fixed because we are at a particular point, even when the body rotates this r is not going to change, therefore this is 0 for a rigid body. For rigid body motion we have the important relation, this is 0. We will simply have v is equal to v theta E theta, and v theta is we know is r omega. What happened when r theta dot r is r theta dot is omega times E theta. Now this is for rigid body r dot is 0, that is why this relationship is coming from here, r omega. Now I will differentiate it further. Yeah, I need that space. What time is sir? 4 minutes. Okay. Continue. Okay. Now I will calculate acceleration. Acceleration is equal to dv by dt. This will be d by dt of r omega. This will be d by dt of, we will start from here, r dot er plus r theta dot E theta. So this will be, first I will differentiate this, they will have r double dot er plus, then I differentiate, keep this r dot constant, d by dt of er plus next dr by dt theta dot E theta plus r times, when I differentiate this I will get theta double dot times E theta plus okay. So we have this expression for theta here, even though I did not write it, it was very clear, minus sin theta Ex plus cos theta Ey. Okay. Therefore this is equal to r double dot er, this term will be there, r dot into d by dt of er we have calculated, we have here E theta times theta dot plus dr by dt is dr by dt is r dot theta dot E theta, unit vector I forgot to write here, plus here I have r double dot or theta double dot E theta plus, what is the time derivative of this, d by dt of E theta is equal to minus sin theta, if I differentiate sin theta I will get cos theta Ex plus minus sin theta times unit vector y times theta dot term. Remember, sin is a function of theta, theta is a function of time, therefore theta dot has to come. This we know what it is, cos theta Ex. If I remove this minus sign, I will have minus of cos theta Ex plus sin theta Ey. Therefore, I will have this relationship d by d theta of E theta is equal to minus I will have minus minus theta dot E r minus theta dot E r. So, I have here minus theta dot E r. So, I have here r double dot minus r theta dot squared times E r. I am clubbing this term and this term, and then I will have here plus r, this is these two terms are the same. I will have r theta double dot plus 2 r dot theta dot, both of them are in this direction. Time irukka? சரி சரி, நாளைக்கு நான் பார்த்துக்கிறேன் எங்கே கட் ஆச்சுன்னு. You will see that r double dot is 0. So, this I will call it as radial acceleration. This is radial, this is AR ER plus A theta E theta. So, the acceleration will have both radial components as well as theta components. Now, you see that for a rigid body r is fixed, therefore, I will have for a rigid body for any point on the rigid body, that is what I mean, rigid body. Therefore, I will have the radial acceleration is equal to minus r theta dot squared, and angular acceleration is equal to, again this will be 0, r theta double dot. So, from this it is very clear that what, for a particle on a rigid body there is no radial velocity, but radial acceleration will be there, whereas both and r theta components will be there for the acceleration. Okay. So, tomorrow we will calculate these quantities and then see that whether they gel with the results. Thank you.